Hello, everyone. That's a Service Mesh with Istio series. We have here a GitHub page that you can follow from Raul Ray, our speaker, and you have all the demos that you can clone this repo. You also have the Katacoda course. You can just click. We are going through all the scenarios. You can also get the Docker image used by the demos on the DockerHub, Fast Track Istio.
So let's move on to the exact topic of discussion in this workshop, Istio. So Istio was built by Google, IBM, and Lyft provided it with the sidecar proxy Envoy. So that's where what most of the service meshes use as a sidecar. So it was the joint collaboration of these three companies that brought Istio to market. Istio can be deployed to VMs or Kubernetes, but what I personally find is that it is a good fit for Kubernetes. With VMs, it is much harder to configure and get right. So I haven't really experimented much with implementing Istio on VMs, but feel free to do that. It must be quite a fun activity. Since Istio runs as a sidecar in parallel to your workload, it's quite decoupled from the actual workload. You can keep making and deploying new versions of your workload without worrying about many of the policies that Istio implements. Because of all the programming constructs that it has, it can manage security, policy, and observability for your applications independently of your application. We'll now dig into some of the core features of Istio. We had been talking about service mesh in general till this point, but we'll see some of the core features of Istio now. So one of the very core features of service mesh and also Istio in turn is traffic management. So it provides several APIs that can help you implement, shape traffic in whatever way you want. You don't want service A to talk to service B possible. You want a bunch of users to be exposed to a version of service A and another bunch of users to be exposed to another version of service A, then that's also possible. So it manages the discovery of services for you. So the physical location of a service need not be known to another service which wants to communicate with it. It internally uses core DNS, which is the DNS server available within Kubernetes for recording addresses of services, but it does that in a very transparent manner. You don't need to know much about it. Just use the name of the service and it will automatically route traffic to an instance of the service automatically. Pretty much how you do it in Kubernetes as well, but you'll soon see it's much easier. Sidecars run in parallel to your services, and that's how all of these traffic policies are implemented. Any traffic to reach your service has to go via a sidecar, and that's where most of this traffic shaping takes place. And all the policies are implemented in the sidecar, and only the traffic that satisfies all the criteria, all the policies that you implement on the service mesh would make its way to your actual workload. Observability, it has beautiful dashboards that you can use, and quite useful at that, to see what's happening inside your cluster at any given point of time. And some of my favorite dashboards that Istio provides are Kiali and Jaeger. So I've seen teams implement their own versions of logging and telemetry, and most of the time the problems that I have personally faced is that with multiple teams implementing their own version of telemetry and logs, is that one of the teams would implement it in one way, some other team would implement it in a different way. Now you have to correlate these logs together and find out the root cause of any problem, as in if traffic flows through multiple services and then satisfies its duty, then it's very hard to find out which service broke down where and pinpoint the exact root of the problem. So because there is a sidecar running in parallel to your workloads, Istio can pinpoint issues very easily and say that, all right, in this particular chain of communication, this service broke down in between on this request. So you can go and fix your issues quite easily. It implements most of the common telemetry protocols. It uses distributed trace. It comes bundled with distributed tracing services like Jaeger and Zipkin that you can use out of the box. You don't have to write even a single line of code to configure telemetry. A bunch of other observability services as well that we'll soon see. Again, one of the very key reasons why service mesh are implemented is security. So let's say you have many pods running in your cluster at the same time. Now you want to, all the communication between these services, you want them to be encrypted, because attacks can not only happen from outside your cluster, but they can happen within your cluster as well. So if someone injects in a rogue pod in your cluster and your services are talking to each other without encryption, it's very easy to just pipe all that data out of your cluster, move it to somewhere else. So you want to avoid that. You want the communication within your cluster to be encrypted as well. So you don't need to do anything extra. Just implement a particular networking API of Istio, and it's all taken care of you. So not only that, in addition to the encryption of channel, you can also authenticate and authorize pods to talk to each other. So you can assign an identity to each service, and it can use that identity to talk to another service. The other service can decide whether it allows that the service with that particular identity to connect to it or not. Basic things about identity, everything taken care of by Istio. You don't have to program it within your applications and don't have to spend even a dive extra to get these features implemented. Let's quickly talk about the architecture of Istio. We have already seen the generic architecture of a service mesh. So how that architecture translates to the real architecture of Istio. So Istio has a daemon running as its control plane. The daemon has a bunch of small components all packaged into one single binary. This is quite interesting, as an Istio used to be a microservice in itself. So the components that you see here, Pilot, Citadel, and Kali, all of them used to be a service on their own. And when you deploy Istio to your cluster, you would see a bunch of services getting created and running at the same time. And most of these implementations were very chatty. So your Envoy proxy would send thousands of requests to the three components that you see here, the Pilot, Citadel, Kali, and which would add to a lot of latency. It's a great thing that they did. They combined everything, made it very simple. Ultimately, those binaries still exist, but packaged within. Those applications still exist, but packaged within a single binary.
Yep. that's a nice thing. I think when I started using Istio, it used to be separate, you
Yeah.
know, and now was kind of, you could update one component. Now we have to update the whole thing, but
Yeah.
looks like it's more, less flexible, but become easier and to maintain.
Yep. So microservices are not always a good thing.
Yes.
uh, Especially chatty microservices are always a bad thing.
It's similar
So
to what happening with Kubernetes and in K3S from Rancher.
yeah,
It's trying to combine and become simple, but that's a
yeah,
good thing.
exactly. Uh, so uh, I'll briefly talk about each of these components internally. So starting from the right, Galley is used for issuing certificates, mostly to your Envoy proxies. Citadel is uh, and so is for discovery, and so it manages the visibility of different services. Pilot is used for policy distribution. So you send it the policy, it will distribute it. Any policy that you send to Pilot ultimately goes to Envoy proxies. So if you look at it as in how I see it, that and yeah, it is in general true, is that all the policies ultimately reach the Envoy proxy. So it's not that for checking the policies, the Envoy instances constantly have to talk to the Istio daemon. These policies are pushed once to the Envoy proxies, and if there are any updates, it's at that moment that the Istio daemon would push these policies, policy updates back to the Envoy proxies. Otherwise, the communication, there is very not as much communication as there used to be there when Istio in itself was a microservice, was made up of a bunch of microservices. The communication is pretty much reduced. The components within Istio still talk to each other, but since they are within a single binary, it doesn't add to a lot of chats going on within the cluster. So with that, we are quite close to concluding this part of the series of videos. So how do you install Istio to your cluster? So there are a bunch of options available. First is to use a CLI of Istio. It is called Istio, just like kubectl. The other one, which I often recommend, is using an operator. And operators are just in addition to the existing programming constructs available in Kubernetes. So just like Istio adds a bunch of programming constructs to your cluster, we'll see that a standalone an Istio standalone operator has the possibility to install Istio to your cluster. That's what this operator does. It has no other job. You specify it using a YAML file, just like you do any other specification within Kubernetes, and you use that to install Istio. One of the popular ways in which Istio was installed earlier was using Helm charts. Helm charts have undergone a massive change themselves, but they are not that much used nowadays, since a much more powerful way of installing it via operator is available. So we'll move to demo now.
I like the Helm chart. I think still some people move away, but still trust me, a lot of people using that.
So my platform of choice for as far as Kubernetes is concerned is AKS. So in order to save some time, we already have an AKS cluster running. I provisioned it using a bunch of scripts which I'll talk about later, mostly Terraform. And I found a really cool trick with how you can use Ansible and Terraform together in order to deploy whatever resources you want on Azure. You heard it first on AzureTar. We'll do a video in future about it. But essentially, once you have your Kubernetes cluster up and running, then what you need to do is we need to execute some scripts to it. So let's walk through the scripts quickly. So the first script that you would see that we are going to run is would download the binaries of Istio to our system, and it will download the binaries of Istio command line, which is istioctl, to our system, and it will put it on our path so that we can use it later. Once istioctl is downloaded to your system, the first thing that you do is it also comes with the binaries for the operator, the application, the thing that we would use to deploy Istio later. First run the init command, then you create a namespace for Istio. So everything that all the services of Istio would go live within this particular namespace. In general, you would see that people name it Istio system. That's what the documentation recommends as well. But you can change it, but there is essentially no need to. Once you do that, you need to apply a spec to your cluster. I have highlighted the spec, but you would see that as I was saying that said earlier, that by installing istioctl, you get a new programming construct that you can use in your Kubernetes cluster. In this case, the construct is Istio operator. Just need to apply this spec, and it will apply the latest version of Istio to your cluster. You can obviously control the version of Istio that you want to deploy. Otherwise, it will keep deploying the latest version. So in order to run this script, I will use my fancy terminal. I have a link to how you can set up a terminal like this on my GitHub. Search for the PC init repo, and you would be able to set up a terminal just like mine with IP address and with weather conditions and this fancy almighty.
That's nice. That's nice, man. I think you have to record SSL with us because we're doing a lot of things, and I see that you're using Z shell, and yeah.
Yeah. So now I'm going to do a little bit of copy paste because I'm very bad at typing commands when I'm doing presentations. So I mostly rely to try it and test it approach. So we have packaged the command within a shell file called install istio sh, and it will execute these commands in a sequence. You would see that my Kubernetes context is set to my the recently created cluster on cloud. So all I need to do now is just run this command. Yep. So you can see that all the components of Istio are running now, which means that Istio is now up and running.
Great.
So I will demo another thing, so which will bring people to one of our other videos. So there is an Ansible playbook that I wrote that you can use to set up your cluster, destroy your cluster, and change its configurations just by specifying a file that it should pick up. So yeah, now that we have gone through the demo, I will destroy the cluster using the Ansible playbook. So we'll look at it in a subsequent video. If you want to know more about Istio, follow this series, then give us a like on YouTube, and also follow our channel. And for more cool stuff, please subscribe.
That's great,
Thank you.
Raul. That's great. We're going to have all the parts and see what we have installed and how that works on the
Yep.
next part. Thanks, Fernando, for joining us. Thanks, Raul. See you guys soon.
Thanks, Raul. See you.
Bye-bye. If you want to follow Raul Ray, our speaker, just go for his blog, thecloudblog.net. There's a lot of blogs here, a lot of content. You can see links for his books. One of the books is the Istio book, just released a few months ago. It's a very nice one. I really like the Kubernetes one as well. Have had a look before. And also, Raul is one of our bloggers and mentors. There's a few blogs here on azuretar.com. Please follow our blog. And Raul is here as one of our main mentors. Thank you for following and helping. The community is all about helping others to publish content. Thank you.